right, so fill in the blanks. P-value is the what? What's the p-value?
The probability of getting something out of
Yep, it's a probability. So p-value is a probability of getting a sample as extreme. Yep. Extreme as yours. If it's very, very small, it indicates that the null hypothesis is probably not true, so we're going to reject the null hypothesis. So in other words, when p-value is less than alpha, less than or equal to alpha, we reject the null hypothesis. So for example, that one with the whole the girl baby thing had a z-score of 1.60, and the area on the right was 0.0548. That would be its p-value. So here, we would not reject the null hypothesis because it's not equal to or less than alpha. It's not 5% or less. So we'd say, oh, it's usual. It's not unusual. All right, so this is kind of, so you folks are familiar with this picture a little bit now, but let me point out the part that is relevant. So here's my test statistic. Now I can see my test stat right here. Right, everyone see that? The area in the tail is the p-value. In other words, what percent of people are here or further out? So that's the probability. Here you can see it's totally guilty, right? This area is less than alpha. Alpha is the red area. So totally going to reject H naught. It's unusual. Here's my test statistic. So this whole space here would be my p-value. Does that sort of make sense? The area to the outside of it. And you can see this is bigger than alpha. It's 0.064. It's bigger than alpha, so would not reject H naught. Where it gets a little bit tricky is
But if it's less than alpha, we do reject it.
if it's less than alpha, we reject the hypothesis. This is where it gets tricky. Is two-tailed. So here's my test statistic. You would think that maybe this is my p-value, and this is 0.032, which is definitely less than alpha. Alpha's 0.05, but look, it's in the do not reject region. That's because it's not fair to compare this to all of alpha, because alpha split half here and half there. We should be comparing it to half of alpha. Does that sort of make sense? So really, you'd have to multiply it by 2 if it's two-tailed. So instead, don't worry about finding alpha from your test statistic. Instead, just use hold on a second. Use the t-test or 1 prop z-test, and it will do that for you. If you tell it's two-tailed, it remembers to multiply it by 2. Right, so it will take care of all of that. All right, so here's the deal. I just want you folks to be able to apply the p-values. Again, if it's unusual, it's, for example, our general guide for unusual is what?
Under 5%.
5% or less. So if your p-value is 5% or less, it'd be unusual. I decided to change my alpha to be 10%. We can do that now. So if my p-value is alpha or less, you would say it's unusual. If it's unusual, you reject the null hypothesis. So go ahead and go through lab problem 1 and figure out whether or not we're going to reject the null hypothesis. Okay, so I want to make sure everybody's on the same page. So first of all, you do not need to multiply it by anything, right? You've used the calculator. It's already found the p-values for you. These are them. So the very first one is 0.107 unusual. Is it alpha or less? Is it 0.10 or less? And if you're having trouble telling, this is how you can tell. Alpha is 0.10. My p-value is 0.107. Make them have the same number of decimal places. So this one has 3. Add more zeros so that one has 3 also. Which one is bigger?
107.
Yep. So here it's bigger, so we would not reject H naught. Everybody on board? Okay. So go ahead and do B and C. I'll give you folks another minute for that. Okay, the next one. P-value is 0.043.
Reject.
Reject H naught, that's less than 10%. And the last one? Yep, do not reject. This is not less than 10%. Everybody all good with these? Pretty straightforward, yeah? Okay, good, good. Now, here's the tricky part. Please do not confuse p-value with proportion p. Annoyingly, your calculator calls it p. Doesn't call it pb. Why can't you call it pb? How hard would that be? It calls it p. So you've got p hat in there, you've got p naught, you've got p, which is really your p-value. So I don't know how you want to do that. Maybe you do decimals for one and do percentages for the population proportion. I don't know, however you want to work it. But make sure you just keep track of which one's which, because they get a little bit confusing. There's a lot of p's floating around. All right, how do you find it? You're just going to use the calculator. Stat test 1 prop z test. And you'll input your p naught, your x, your n, and then what type of test it is, what your h1 is. And then for a mean, you do t-test, input your mu naught, your x bar, your s, and again your n, and then also your what type of test it is. So it's fairly straightforward, and it gives it to you. All right, so here are the steps. I wrote them down for you, but they are important. Despite the fact that you don't have to write them down. Next semester, they'll have to write them down. Jason, go ahead and read for us the steps.
Step 1, state the hypothesis and identify the claim. Step 2, write down alpha. Step 3, find the p-value. Step 4, make the decision. Compare alpha and p-values. Reject if p-values greater than alpha.
Less than alpha.
Oh, less than alpha. And step 5, summarize the results.
Great. Perfect. So we're going to go through an example. You're going to do this one with me, bottom of page 59. Here is the, Shaylee, go ahead and read for me.
The Gallup Crime Survey stated that 23% of the gun owners are women. A researcher believes that in the area where he lives, the percent is less than 23%. He randomly selects a sample of 100 gun owners and finds that 11% of the gun owners are women. At alpha equals 0.01, is the percent of female gun owners in his area less than 23%?
Perfect. All right, so the first step, first thing I find all my pieces. So what's my claim? Right, figure out what your claim is. What's my claim?
23% of gun owners are women.
Well, a researcher believes, this is his statement, he believes what?
Percentage is less than.
The percentage
is less than.
P is less than 0.23%. Is everybody okay with how I found that?
Yep.
So this is what someone believes. So then he ran. So first of all, I should be able to find my H0 and H1 all off of that. So step 1, and I like it if you can put a 1 and circle it. H0 is always what?
Equals.
Equals. So is this going to be P equals or mu equals?
P.
P, it's a proportion. There's a percentage. P equals what?
23%.
23%. You can either do 23% or 0.23, I don't care. H1 then would be what? Oh, sorry. Yes, so is that my claim?
No.
No, so then H1 has to become whatever my claim is. What's my claim?
Less than 23%.
So that's my claim. I'm going to write claim next to it. And then in parentheses, I'm going to write the word support, because whenever H1 is our claim, we're going to either support or fail to support our claim. Step 2. Write down alpha. What's my alpha? What was that? 0.01. Alpha 0.01. There we go. That's it. Easy, right? Step 3. Find my p-value. So I'm going to do, this is a proportion. I'm going to do 1 prop z test. And let's see what I'm going to put in there. What does it ask me for? 1 prop, it's asking for p naught, which is 0.23. Then asking for my x. Oh, I don't know my x. Aha. So I'm going to put in 0.23. I got to find my x. So 11% out of 100 are women. So my x is equal to 100, 11%, 0.11 times 100.
So that's just 11?
11. Yep. So 0.23 comma 11 comma my n, which is 100. And then it was my H1 is less than. So go to the less than and hit enter. Right, so it says that I am less than P naught. Right, P naught is 23%. So I'm less than 23%. And calculate. Bam, there it is. My p-value is, oh wait, what else did I put in there? I put in
The less than sign.
point, oh yeah, I put just less than.
Yeah.
Okay. And then my p-value is 0.002 18. 3 sig figs. Okay. Everybody feeling okay with this part so far? Next, number 4. Put a circle on that one. I'm going to compare my p-value to my alpha. So my p-value, and I'll write it again, 0.00218. And I'm going to write alpha, which is 0.10. And I'm going to make it have the same number of decimal places. It makes it easier for me if they both have the same number of decimal places. So because this one has 5 decimal places, I'm going to make this one have 5 decimal places. It's just easier to compare them that way. So 1, 2, 3. Now to look at it. 1,000 versus 218. 1,000 is totally bigger. Is everybody good with that part? So that means that it's less than alpha. I'm going to reject H naught. And then my last step, because I rejected H naught, do I have enough evidence or not enough evidence? You have enough evidence, exactly. If you reject H naught, you have enough evidence.
Wait, so when we reject it on 4, we have enough evidence, but
Yep.
when we do not reject it, then we don't have enough evidence.
Yes. If we reject it on 4, then we have enough evidence. When we do not reject it on 4, we do not have enough evidence. Exactly what Marie just said. Okay, good. So we rejected H naught on step 4, which means we do have enough evidence. So enough evidence to blank the claim. So you kind of think about it like this. There's blank evidence to blank the claim that the proportion, and then write down what the claim was. What was my claim?
That the percentage is less than 22%.
Yeah, the percent of female gun owners is less than 23%. Now, these pieces here get filled as follows. This one comes from this one. If I reject H naught, that means I have enough evidence. The other one This one here comes from step 1, support. In other words, we got something unusual, and we're going to say, whoa, wait, the percentage of female gun owners is totally less than 23%. It's something closer to 11%. Right, so we did have enough evidence to support the claim, say yes to the claim, we are less than. And it's strong, there is enough evidence. Okay, so let's have you folks try one. See if I have anything prettier. I might have prettier. Let me see. All right, so here it is, prettier a little bit. Right, H naught is P is equal to 0.23, H1 is P is less than 0.23. I don't need to do this one. We're just writing down alpha, so that's a little bit different. So then we get, this is just alpha equals, that's right, I'm not worried about that. And then step 4, because our p-value is less than alpha, we're going to reject H naught. And then finally in step 5, there is enough evidence to support the claim. Female gun owners in that area is less than 23%. So on the next page, on page 60, you folks have lab problem number 2, female positions. Go ahead and do it. Okay, so first of all, is this a mean or proportion?
Proportion.
How do you know?
Percentage.
It says percentage, yep. It says proportion as well. This is going to be it's a hypothesis test, and it's proportions. So the percentage of physicians who are women is 27.9. That's sort of my statement. Is there evidence, this is getting into my claim, to conclude portion of women physicians exceeds, this is kind of where I get to the meat of it. Right? This is where my claim is. Is there evidence to conclude? Concluding things is sort of like it's kind of a claim. You're also going to have these, so this is going to be in your claim. Remember that's always P naught. And you have your sample. 120 random selected, 45 of them. That's your, is 45, so 120 is my N. What's 45? Is that my P hat or is that my X?
X.
X.
How do you know?
Whole number.
It's a whole number, yep. And then don't forget your alpha is 0.05, which is pretty standard. Okay, so you want the steps back up there, or does anyone have you all have the steps on the previous page? Okay, here's another reminder. Remember that your P naught or your mu naught is whatever is in your claim. The number in your claim, that's going to be your P naught or your mu naught,
Yeah.
always.
Yeah, that's what I have to do.
All right, so let's take a look and see what people have. So for, who has it done and has neat writing?
Oh. A little bit.
Let me see. Okay, I'm going to put this on pause for a second. Okay, it looks good. Jason, do you explain what you did? Let's up through it.
You want me to?
Yeah.
Well, I don't know how to explain. I kind of just did it in my head.
Okay. Well, how'd you get H naught is P is equal to 27.9%?
Well, because that's the claim.
Okay. Oh, yeah, it comes from the claim. The claim is, what's the claim?
That the P's greater than 27.9.
Yeah, so that's your claim. Which why you, oh, look how you put the word support next to that. That's awesome. And so then H naught would be the same thing, only equals. Great. And then alpha 0.05, because that's your alpha. Terrific. And then you use what in step 3? Just say what you did.
I converted the percentage into a decimal, so this would be 0.279. And the 45 is the 45 out of, that's the
X, yeah.
X. And then 120, that's the N.
Great.
I'll put the little,
And you put that into one prop z-test,
Yeah.
and you end up with a p-value of,
0.00952.
great, and then step 4.
I compared the p-value with the alpha,
Mm-hmm.
and I rejected the H naught.
Perfect.
And then for number 5, I just put enough evidence to support that claim that percentages of physicians are women exceeds 27.9%.
Perfect. Great. Yeah.
We're only trying to get more than that though?
Right. We're trying to say that it's more than. The p-value, if we're trying to see if the p-value is unusual or not. What's our general guideline for unusual?
Less than 5%.
5% or less. Right? So if it's 5% or less, if it's alpha or less, it's unusual, I'm going to reject the null hypothesis. Does that sort of make sense? Now our claim is that it exceeds. So our claim is that's bigger, 45 out of 120, that's way bigger than 27.9%. If you look it up, it's probably in the neighborhood of like 40%, something like that. So you're comparing the p-hat to what you expected to get, 27.9%, and if it is the same, then the p-value would be pretty big. But it's super unusual. It's very unlikely. Like less than 1% of the time are you randomly going to get something that extreme. So again, because this is less than alpha, it's alpha or less. It's unusual, which means we reject the null hypothesis, which means we have enough evidence. And then like you did in the first step, because our claim is H1, that supports our claim. Great. So what we're doing this whole time is the conservative or the traditional method compares z-scores, so it compares the test statistic to the critical values. And then what we're doing here is really what most people do nowadays, which is comparing p-values to alpha. All right, so we're going to do another one. We're going to do a t-test now. Let's get a reader for this one. Chris, go ahead.
A physician claims that joggers' maximum volume oxygen intake is greater than the average of all adults. A sample of 15 joggers has a mean of 40.6 milliliters per kilogram and a standard deviation of 6 milliliters per kilogram. If the average of adults is 36.7 milliliters per kilogram, is there enough evidence to support the physician's claim at alpha equals 0.05? Perfect,
thank you. All right, so first of all, I have evidence and a claim. So this is going to be a test. But is it a proportion or a mean? What do you folks think?
A mean?
Proportion or mean? Everyone take 30 seconds with your neighbors and decide what you think is a proportion or a mean.